So this was a command that we used using the PLM. We were running the pooled OLS. We explained in total everything about the pooled OLS. And I'm sure you all remember the pooled OLS. We even formulated it. And we got this result in the pooled OLS. And what we are going to do today is to understand the intricacies of this result. Ladies and gentlemen, please remember that this result was about some young people, 17 to 23 years, who have just entered the labor market, have few experience, were able to model them. They believe that education can affect their wages or returns. There was a belief that experience, whether they belong to a union or not, whether they were married or not, the race, all of these can affect. We assumed that there was no presence of heterogeneity. That was a pooled OLS. The pooled OLS assumed that time doesn't matter and consider every individual in every time period as separate from the same individual in another time period. We did a pooled OLS, and this was the result. In an exam situation, the important thing that will come in the results are the following: the estimate and the standard error. That is what you will see. And then you will get a star, 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 indicating whether that particular estimate is significant or is not significant. Now, what we are going to do today is to interpret some of the results regarding, remember we gave a thesis title to this. So first question, please, if you can answer it, just raise your hand for us and I'll unmute you. Which independent variable has the largest coefficient interpreted? So who can tell us which independent variable has the largest coefficient? Who has a clue to this? Looking on the screen, which independent variable has the largest coefficient? And interpret it for us. It is the interpretation I'm interested in. As for choosing which one is having the largest, you can see it and then just type. But I'll need someone to raise their hand and interpret it for us. Who will do that for us? Who will do that? And if you are in this class and you are used to not commenting in this class, then you know the consequences of that. But I can't tell you much, but you should know the consequences of that. It won't be clear now, it will be clear after your exam result. If you are not used to that, please do. Who will tell us the interpretation? Which one, by the way, has the highest coefficient, and how would you interpret that higher coefficient? Which independent variable is that? And I'm looking at the independent variables, and there's one particular one which has the highest coefficient. Which one? Okay. David says it is union. It is union. Is that true? Is it union? Well, look at the coefficient. But remember, this was a log of wage. This was a log of wage. If you look at the coefficients, all of them here, you will notice that union is the one that comes the highest. Okay. If you look at it here, you will notice that union has the highest coefficient there than any other one. Okay, Philomena's hand is up. Philomena, let me see. You want to try and interpret it for us?
Yes.
Yes, go ahead.
So we can say that on the average, those workers in the union are probably earning wages 18% more than the workers not in the union.
Good. And using the stars here, what would you add?
And this is significant at 0.1%.
Okay, this is significant at 0.1%. That is it. That is exactly the case. Now, I like your point of 18% more. The usage of the percentage was why? Who can tell us why was it 18% more? Why was it 18% more? Philomena, you can answer it yourself. Why was it 18% more? Why percent? That's what I mean. No,
okay.
Somebody says it's positive. No, it's not because it's positive that it's percent. Why was it percent? Why didn't it say 18 units more? Philomena, you're thinking about it. Let me give it to Gabriel Kwanche.
Yes.
Gabriel, why was that?
Doc, I think it is because it was logged.
Exactly. Because the dependent variable was logged. That is the thing. The dependent variable was logged. And when the dependent variable is logged, then you are going to be interpreting the coefficient in terms of percentages. Please note that. Please note that that is important. Okay. Now, let's go to the next question. So this is the point that she said. Okay, on average, and please all the time try and bring the on average. Okay. Bring the on average, because if you bring the on average, you are able to make the point very clear. Okay, on average. Holding all other factors constant, I normally tell students to prepare to mention all of those factors, so that you know that those factors are there. Or some people mention ceteris paribus when they are not even aware what are those factors that are there. All right. A unionized worker will earn 18% more than a non-unionized worker. And this was significant at 1%. Remember, union is a dummy variable. And the way you interpret a dummy variable, you don't say that a 1 unit increase in the union. No, union doesn't increase. So the way you interpret dummy variables is completely different from the way you interpret. Okay? You say that you are either a unionized worker or not. And if this was a journal paper or a thesis you're writing, you have to interpret it like this. You have to put it like this. And you have to mention the coefficient and the t statistic. Okay? So this is a t statistic. You put that down to indicate that you are speaking from exactly how you are speaking. All right. Now, what is the estimate of the return to education? And can you interpret that for us? What is the estimate of return to education? Who can tell us? What is the estimate of return to education? Who can raise your hand and tell us the estimate of return to education? And can you interpret that? By the way, the first question is, what is the estimate of return to education? What is the estimate there? It's like asking the question, what is the coefficient of education? That's it. What is the coefficient of education? Okay, so you got Philomena again. Let's raise a hand. Yes, what would you say, Philo?
From your screen is 0.091, so like 9% or 9.1%. The estimate.
So how would you interpret that? Can you interpret that? Can you interpret that? If anybody thinks that he or she can interpret that, please let me know, because you should be able to interpret that. Okay, let me give it to Grace. Let me give it to Grace to try. Grace, yes.
On average, holding all variables constant, a 1 unit increase in education would increase the wage rate by 9.1%.
Okay. So guys, what did she miss? Who can raise her hand and tell us what she missed in her interpretation? She missed something. What did she miss? If you were listening carefully to her, you would notice that she missed something. What did she miss? She mentioned something which she's not supposed to mention. Did you realize that? Let me give it to Gabriel. Yes, Gabriel, what did she mention that she wasn't supposed to mention?
Yeah, he mentioned that 1 unit change in education, whilst we have all agreed that when the independent variable is logged, we do not use unit, but we use percentage change.
I like the way you say we've all agreed, as if she was part. As if she was part of the agreement and spoiled the agreement. Okay, so how would you interpret it now? How would you have interpreted it now? Roxanne, do you have a way you would interpret this? How will you do the interpretation? Yeah, Roxanne. Yes, Roxanne.
Hello, Doc.
Yes.
Hello, Doc.
Go ahead, we are all ears.
Yeah, to me, I would say holding all factors on the average. Yeah, on the average, holding all factors constant. A 9% increase in educational level will lead to an increase in wages. In wages of a worker.
That is wrong. That is wrong. Okay, because that 9% was not increasing the educational level. Okay, but let's go to another person who will do the interpretation. There's a reason why I'm going through this exercise, because people have made mistakes in journal articles when it even comes to the way they got to do interpretations, and this is becoming clear here. So let me go to Eric. Eric, how would you have done this interpretation?
Okay. So I would say that on the average, a 9% increase in salary would come with a 9% increase in salary would influence the level of education.
No.
No, education.
Let's let somebody pick it up, okay? Just process your thoughts and come back again. Let me give it to Prince. Okay, Prince, you interpret that for us. Oh, Akute, sorry.
Yeah, so Doc, what I think it is that on average, holding all other factors constant, someone with an education is likely to get a 9% higher salary than someone who doesn't.
No, I didn't like the way you put it. Someone with an education. That one, someone with an education, you're making it like a dummy variable. Okay? But in this context, it's not a dummy variable like the union. So we'll pick it up again. Let me take it back to Prince. Let me take it back to, remember, this is a dynamic variable. Prince.
Okay, Doc. I would say that on the average, holding all other variables constant, a 1% increase in education will lead to a 9.1% increase in wage.
Good. And is this significant at what level? This is significant.
Hello?
Yes, and I'm saying, and this is significant at what level?
Hello?
Yes, Prince, can you hear me? Can you hear me, Prince?
Hello?
All right, I think we lost it, no problem. Philomena, this is significant at what level?
0.1%.
Exactly, this is significant. You see, when you do these interpretations, you got to mention the significance. It's very important to add at what level it is significant. Because when you don't add that one, your interpretation is not complete. Okay. So that was education. Can you imagine? So the 9.1%, okay, this is significant 0.1%. So a 1 percentage point rise in education. Now, I don't know who, but then Nakute, when you were mentioning that if someone has education, no, it's not if someone has education. If someone's education he already has rises, he already has it and is rising. It's a changing variable. It's a dynamic variable. It's not static. It's not a dummy. And so education is rising. But anytime it rises by 1%, then wage rate is going to rise by 9.1%. All factors held constant. Interpretation is very important. You see some people making mistakes in some of the papers I give. Okay, let's go to the marital gap. The marital gap. Someone will say that, what about a marital gap? And the marital gap has to do with marriage, yes or no? Okay. What would you say about the marital gap? How would you interpret the marital gap? You can try that for us. So we are talking about the marital gap. This is a marital gap. Who can interpret that marital gap, remembering whether it's static or dynamic, and then completing it with that of the significance level. This is where I need you to be part of what is happening. Okay. Gilbert Mombasa. Gilbert,
okay.
Gilbert.
So I would interpret it as follows. On average, holding all everything else constant, a married man earns above 10.8% more than an unmarried man. And this is significant at 0.1%.
Good. Can you take it again?
Sorry, holding all other things constant, on average, a married man earns about 10.8% more than an unmarried man. And this is at 0.1% significant level.
I think this is good. This is a good interpretation. Now, stay there, don't go, Mombasa. Does it make sense to you? Is that plausible? Is that real in those days? Remember, this data was very long. Does that make sense? And why? If you don't know that it makes sense or not, let's say pass.
Okay, so I will say it makes sense.
Why?
Because from the statistics, that's what it speaks. So it makes sense.
Oh, I understand. Okay, take away statistics out of the picture. Let's go to Portia. Okay, Portia, does it make sense? Where is she? She's gone. Okay, let me go to Francis. Francis Fiaiya. Francis, what would you say?
Yes, it makes sense in that if somebody is married, the person could have reliefs, tax reliefs, or incentives for married people, which others without same condition will not have.
Okay, okay. Have you heard of the statement that, okay, Emmanuel, Jabba, do you want to ask something?
Yes, sir. Yes, sir.
Go ahead.
And I think also if you look at how things work in the society, married people most likely tend to be older than unmarried ones, meaning that they have been working longer. So it makes sense that they will earn more.
Okay. So have you heard of the statement that says that single people are footloose? Single people, they jump from company to company. And that most of the time, married people normally tend to stay in one company. Part of the reason is because they have a family and they want to stay by the family. A single person can be moving from here to there, to there, to there, to there. And so they are footloose. Married people have also shown some level of commitment already in life, which is their marriage. And so they are more likely to stick by a company, even when things are a bit rough, because they have seen that in the marital world. So on the basis of that, in those days, of course, probably today it may have changed, but in those days, there was this belief that when a person is a married person, you pay the person more, part of that reason, and also the person is having a family. The person is having a family, so he's more likely to need extra income than the single person. Of course, today you can't do that, okay? You might not be able to agitate for that because somebody might say that, oh, I'm single, but I'm taking care of 200 million people or 20 people. And that can alter the whole scenario. But in those days, remembering the data we have, that seems to make sense. Not statistically even, but we are now, you see, this is where whenever you're writing your thesis, you give an intuition behind the statistical paradigms that you are seeing. So the statistics is telling you something, but you got to make sense of the statistical ambience. And that is a critical factor there. Okay, so this is it. On average, a married man earns 10.8% more than an unmarried man. And this is highly significant. So when it is significant, you got to put in all the statistics and the p-value into the picture. Okay, now I'm going to ask you something very teeny, very thinking. What do you make of the estimate of the 1987 dummy variable? Now in 1987, remember in this analysis, we included a lot of dummy variables. All the dummy variables, we included them. Okay. And this is one of the dummy variables, 1987 dummy variable. What can you say about this dummy variable? If you were to interpret it, how would you, remember, this is a time dummy from 81 to 87. How would you have interpreted this dummy? This is not simple because this is not really, it's an independent variable, but it's a time dummy. Sometimes you even absorb them into the composed error term. But here it is not in the composed error term. It's being treated as a real dummy. How would you interpret this? Who will try? Who has a clue? Who wants to be the captain of this ship as far as 1987 dummy is concerned? Now remember, this dummy variables, time dummy variables, they are telling you how wages are increasing over time. That's what they are telling you. They are telling you the increment in wages as time goes on. So you can see that as time goes on, wages was 1981. If you look at 1981, wages went up by about 6%, okay, or 5.8%. And you could see that it was increasing every other year. It was going up again by about 6%, no longer 5.8%. Okay. And then it dipped slightly in 1983, and then went up by 9%, and then 10%, and then 14%. And so by 1985, wages increased by what? By 17%. So that value is telling you how much wage is increasing over time. Okay. So by that 87, wage has gone up. And that is an interpretation. And of course, that was, let's see whether that was significant. Okay. Yes, that was significant upon 1%. And you can see that with a triple star. So when you include the time dummies here, what it does is that it helps to absorb this whole potential of time heterogeneity in there. So this was the interpretation. The value was positive and significant, okay, which shows that all factors constant, nominal wages has gone up by 17.4% over the 8-year period. So always look at the time dummies as what is happening to the dependent variable over that time dummies. So if it is 1987, what has happened to the dependent variable in nominal terms over that time period? Over that time period. And that will help you to know about the time zone. All right. Who can interpret the coefficient of experience for us? Oh, you have a question? That is, Akute has a question. Akute, please go ahead.
Yeah, Prof. So I see 70% for the 8-year period. So it means that it was cumulatively increasing from the base year. Is that the case?
Yes.
But there was a year in which it dipped.
Yes.
Does that mean that the salary decreased, which is unusual?
No, it means that the nominal wage, yes, nominal wage decreased. It decreased, but it wasn't significant. Maybe there was something in that year. This is where sometimes you look at. Maybe there was something in that year and the company says that, sorry, we have to cut down wages by this amount, but we are sure that we are going to really take care of you guys by next year. And so you could see that even though it dipped slightly, by next year it went up significantly as well.
Okay,
by 9%.
Thank you.
All right. Okay, so who can interpret a coefficient of experience? Experience, let me take you back here. Who can interpret a coefficient of experience? Now you guys are getting clearer understanding of these interpretations. Okay? So get used to them. Get used to these things. It's very, very important. Okay. Coefficient of experience. Philomena, I think you have something you want to be able to tell us. Yes.
Okay, so doctor, we can say that holding all variables constant, a 1% increase in a worker's experience would cause his salary to increase by 6.7%. And this is significant at 0.1%.
Perfect. Now I want you to stay there, don't hang up, and tell us what is then happening with the experience square. What does that mean regarding this experience square? Given the interpretation you just made about experience, what would you now say about the experience square?
So if your experience is okay, that is negative 0.002.
Yes, so how will you juxtapose that with the experience square? Somebody should be able to track that. This is a little bit tricky, but who will tell us? Who has a clue? Oh yeah, I got somebody. Let's see. Gabriel, you seem to have a point.
Yes, Doc. I think we can say that in as much as wages are increasing with experience, at some point, if your wage increase beyond a certain point, sorry, if your experience increase beyond a certain point, it leads to a decrease or a slight fall in your wages.
Okay, why? I like that, but why? Somebody has put it on the page. He's made a point very clear there. He says the law of diminishing marginal returns to education. That's it.
Okay.
The law of diminishing marginal returns to education. And the reason is because sometimes you increase your, if you look at some of the footballers, I gave that example the other time, that a footballer will increase his education, However, when it gets to a certain point, the footballer will increase his experience. But at some point, that footballer's experience will dip. It will go down. The days of Messi and Ronaldo are not like now. You know, things have changed. And so it gets to a point, your experience will go down. Age will set in, and it will affect certain bones, injuries, and all of that. And all of this will now, so your experience is not adding up anything to goals. So maybe the rate at which you used to be scoring goals, which is in this case, the dependent variable, will begin to go down. And that is the same thing with some people's experience. And that is why naturally sometimes we tell people, go home, retire, go home, you know, because previously you were using the computer so fast. Now we got young people who are abreast with the technological dynamics of computing. And so the old stuff may have to be relinquished to the background. the statistics is telling us that beautiful story there. And it's always important. And this is a quadratic nature or the non-linearity nature of experience. So when you square a variable, this is where you come and check whether that variable is exhibiting that negative marginal returns. Because now you can see there's a negative marginal returns to education. No, over time. Okay, to experience, not to education, to experience. So that is how you interpret experience. Oh, let's go to the next one. This is critical. The standard errors that you are seeing, the standard errors, are they valid? Are they respectable standard errors? And we are talking about all the standard errors here. Are they respectable standard errors? Why would you answer that? Why or why not? The standard errors, are they valid? Are they valid? Who can tell us whether or not they are valid and why? Whether or not they are valid, whether we can rely on them, whether we can rely on them. And why do you answer that? Who has a fair idea? Because if you have been followed, this is a pooled OLS. This is a pooled OLS. And I'm telling you, these things will catch up with most of you, your work you'll be doing. This is a pooled OLS. Are the standard errors valid? Do you remember one of the things we indicated with the pooled OLS, that it ignores time, unobserved heterogeneity? Okay. And so the standard errors are not valid in a pooled OLS. We got to correct these standard errors. They are not valid because we said that the standard errors will be affected. And so sometimes a particular standard error might make the thing significant. If you look at education, it's significant. Experience is these significance. The standard errors may have caused them to be significant when in reality they may not have to be that significant because the standard error is flawed. And why is it flawed? Okay. And that is the reason. Part of the reason why it is flawed is that there's something we call unobserved heterogeneity. In this case, there is an unobserved individual specific effect. A typical worker has some characteristics, such as ability. So that person's ability has been eaten into his experience or his education. You are saying education is affecting wage. It's okay. You're also saying that the experience is affecting wage. All right. What if there is some unobserved individual ability? A worker has some special ability, and those special abilities are what is making his experience look good. That is what is making him look like. So how do you disentangle that unobserved factor? It's not appearing in the model. And normally when it's not appearing in the model, it's inside a composed error term. The error terms across time periods for each worker might be positively related to this particular unobserved factor. So there may be a lot of correlations, covariances existing, and that will invalidate the OLS standard errors. And please note that the OLS standard errors, it is from that which we get the T statistic. Remember, we always say that the estimate divided by the standard error will give us the T statistic. So the standard error is flawed. And so if you divide the estimate by the standard error, the T statistic will be flawed. And when the T statistic is wrong, it is from this T statistic that you go and read on the table to get the p-value, which is on the far right. And so that will also invalidate the p-value. And so the possibility of the standard of the particular coefficient being significant or not is questionable. We are making a case against pooled OLS to motivate other models. So that is a point there. And this is the explanation that we gave. he indicated that if ability of a particular worker, let's say a Hispanic worker, okay, if that Hispanic worker has some special ability, let's say he can speak some Spanish, which another worker cannot speak, when they have to be taken to Mexico to go and do something, and this person has a special ability and it differs from those of the other workers, now this ability has to be adequately captured in education and experience. But if you don't capture it in their education and in their experience, you are penalizing that worker. And so OLS, pooled OLS will be biased. I'm sure you guys can understand this. It will be biased. You should have collected data on ability, or even if you can't collect data on ability, there must be another model that will take into consideration such ability. So normally when you collect the panel data, what happens is that you allow for this unobserved heterogeneity, this UI. You allow this unobserved heterogeneity to be correlated with the independent variables. That's the idea. When you are collecting data, that's what we do. And we want to allow that unmeasured ability, which is inside the error term, we want it to affect the wage. Because you can't say that it's only the education. But meanwhile, the education, there is an exogenous part and there's an endogenous part. You got to disentangle the exogenous from the endogenous part, so that you know what is truly affecting the wage. And when that happens, it means that ability is supposed to be incorporated, but you have omitted it. So it becomes an omitted variable bias. And if this omitted ability is correlated with educational experience, then the omitted variable bias is going to lead to the OLS bias and inconsistent estimate. It is biased. It means that the true coefficient, the coefficient you had, is not equal to the true value. It is inconsistent. It means that as the sample size increases, the coefficient does not even get closer to the true value coefficient. And this was all happening because of pooling across time. Okay? It doesn't change the basic point. And that's the main problem with OLS. That's the main problem with OLS. Okay. Now, I'll come back to how you handle this, but I want to take you back to the model and check the other diagnostics. One of them is the R square. What is the value of the R square here? And how significant, I mean, how important, how do you interpret it? Who can tell me? What is the value of the R square here? And how do you interpret that R square? Anyway, how do you, today I'm more with diagnostic, how you interpret the values and the variables. How do you interpret this R square? By the way, this is an R square. How will you interpret that? Anybody? How will you interpret this? The value of the R square, by the way, is 19% on average. How will you interpret that? Let me give it to Parenda.
Okay, so on average, 90% of the variation in the independent variable is interpreted by the, in the dependent variable is interpreted by the independent variable.
Okay. So Adjo, let me ask you, if you look at adjusted R square, it is slightly smaller. The R square is 18.9, adjusted is 18.8. Okay. Roughly. Why is the adjusted usually smaller than the R square? Why is adjusted smaller than the R square? Okay, let's give it to somebody to try. Abdul Karimu. Abdul, okay, Akute, tell us.
Because it corrects for overfitting, so that With the R squared, if you add variables, sometimes it still increases, even if they are correlated. But the adjusted R squared corrects with that.
Okay. Okay. So the adjusted R square adjusts for the inclusion of other regressors. Okay. Other irrelevant regressors. So if you put in irrelevant independent variables into the model, the adjusted R square will punish you by bringing the value of the R square down. So it means that whatever values you are putting in, these values must be relevant and sensible. Okay. Are the coefficients jointly significant? Who can tell me yes or no? And how did you know? Are the coefficients jointly significant? Who can tell me yes or no? And how did you know whether it's yes or no? Are the coefficients jointly significant? Who can tell me yes or no? But how did you get to know whether it's yes or no? Grace, what would you say? What would you say to them?
Hello, I think they are jointly significant. Hello.
Yes, yes. Tell us why.
Because the p-value is 2.22.
What p-value? What p-value? There are so many p-values in this table.
No, the one down, the one by the F.
What is the name?
The one after the degrees of freedom.
Whose p-value is that?
That is the p-value for the entire data set.
That is a p-value for the F statistic.
Yes.
Okay. Okay, continue.
So it's 2.22 raised to the power negative 16, which is 0.000 something. So it's very significant at 0.1%.
Okay. So yes, so because of that, we say that the coefficients are jointly significant. So you can see that we've been able to make sense of everything in this information here. And all of them will go into your chunk of write-up in your thesis or paper. Okay. That is where it becomes. But of course, we've already made a point that there is a problem with this. Somebody's asking a question, says, the interpretation of the R square is not clear. Oh, it's not clear or you didn't understand. Okay. The R square tells you how much all the independent variables are affecting the dependent. The R square tells you the variation in the dependent variable as a result of the variability in all the independent variables. So the value of the R square was 19%, which means that 19% of the variability in all the independent variables, including the time dance, 19% of changes, overall changes in them, 19% of whatever variation you get in there will lead to, or is represented by, will have an impact in the dependent variable, which in this case is the wage rate, by that percentage value. Okay. So any variability you see in the independent variables will reflect in a 19% variability in the dependent variable. But it doesn't tell you significance. The R square does not tell you significance. It tells you more or less a kind of an impact. It helps you to know the reliability of the entire regression. It tells you the fitness of the regression model. And so this, and how do we know that the regression model is fit? Well, if you look at the R square is 19%. Okay. And again, this 19%, somebody can write a paper and justify why that is fit. Some people say that when the R square is 50% or more, it means that the data is fit. Another says that when it is 40% or more, the data is fit. I have even seen somebody whose R square is 14%, and he also indicated that the data is what? Is fit. The regression model is well fit. Now, you just need to get a combination, but you see, it's not only the R square that should tell you the fitness of the model. It's not only the R square. We can see that we are using the R square, we are using the F statistic. So the F statistic here is also very important. And you can see that the F statistic is indicating a joint significance. So on the basis of the joint significance of the F statistic, okay, we can say that here 19% of the variability in all the independent variables has been explained. But it also means that there is about 81% unexplained. That is serious. That is serious. If there is 81% unexplained part, that then goes to show that that unexplained part, the pooled OLS did not capture, will have to be handled, which is the reason why we are going to look at the way around that. Okay. So the unexplained part, the 81% unexplained part, okay, what is in there? What is causing that? And that is needed. What's his name? Edward. Edward, do you have a question?
Yeah, I got confused a little bit with the interpretation. Is it that any variability in the independent variables will lead to 19% impact on the dependent variable, or 19% variability of the independent variables?
Is the second one.
Okay, all right, thank you.
Okay, so let's go to the reason why this is happening. The reason why, using the pooled OLS is not the best. What do you do? That's the next part. Okay. That's the next part.